Let's explore table-driven tests. It's a way of testing multiple scenarios with clean and maintainable code, ensuring comprehensive test coverage. Table-driven tests represent a testing pattern. Test cases are structured in a table format, where each row signifies a distinct input-output scenario for the same test logic. This approach promotes reusable test logic, allows for managing multiple test cases effectively, and keeps the testing code clean and maintainable. Here's a comparison between the traditional approach and table-driven tests. The traditional approach often involves writing separate test functions for each scenario, leading to repetitive code. On the other hand, table-driven tests utilize a data structure, like a slice of structs, to define multiple test cases. These cases are then iterated over within a single test function, leading to more concise and organized tests. Let's explore the code pattern. First, define test cases as a struct slice. Include a test name for clarity, and then iterate and execute tests. The tests variable is a slice of structs, each representing a test case. Each struct includes a name, an input, and the expected output. The code iterates through each test case in the test slice. For each test case, it calls the square function with the given input and stores the result. Here's a complete implementation example. The test calculate function takes testing.t as a parameter. Then the tests variable is a slice of structs where each struct represents a test case for the calculate function. Each test case includes a name, two integer inputs, an operator, the expected result, and a Boolean indicating whether an error is expected. The code then iterates through each test case using a for loop. Inside the loop, t.run creates a subtest for each test case, allowing for better isolation and clearer output. The calculate function is called with the inputs and operator from the current test case. The code checks if an error occurred during the calculate function call. It compares whether an error occurred or not with the has error field of the test case. If there's a mismatch, it reports an error using t.errorf. Here are some best practices for table-driven tests. Use descriptive names that clearly describe the scenario. Use t.run for better isolation and clearer output. Test edge cases, including boundary values, empty inputs, and error conditions. Keep test data organized and easy to read. Each test case should be independent of others, and you should test happy path, error cases, and edge conditions to ensure good coverage. Let's see an advanced pattern using helper functions. The runTest function takes testing.t, a name, an input, and the expected output as parameters. t.helper is called to mark the function as a helper function. The calculate function is called with the input and stores the result. If the result doesn't match the expected value, it reports an error using t.errorf, including the test name, the actual result, and the expected result. The test with helper function sets up a table of test cases. It then iterates through the test cases, calling the runTest helper function for each case. Benefits are reusable logic, better errors, and maintainability. In summary, table-driven tests offer cleaner, more maintainable code, better test coverage, reusable test logic, faster test development, and clear test organization. Remember to structure test data in tables for multiple scenarios, use descriptive names and trun for clarity, include edge cases and error conditions, and consider helper functions for complex logic. Start implementing table-driven tests for comprehensive coverage.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.